Hello, class. Today will be the last section before the Unit 1 test. So it's probably going to be best if you print these notes off and then write down your steps on paper where you'll understand how to do these. I wouldn't recommend typing these. And if you don't have access to print these off, then you could write these problems down on notebook paper and work these out with me. And just pause the video if it goes too fast. So in section 1.9, if you follow the steps that I have given you, it's not going to be too difficult, okay? So the first thing we're going to look at is solving polynomial inequalities. Now, a polynomial is going to have many terms. You're going to have exponents, and an inequality is like your less than, greater than sign. So the first step is you want to make sure that it is equal to 0 and that the exponents are starting from your highest power down. The second step is you want to factor and solve for the zeros, like we have been doing in the unit. Now, the third step is you're going to take these zeros and you're going to put them on a number line. After you have put them on a number line, you're going to choose a test value to the left of the 0, between the zeros, and to the right of the 0. These are going to be called your critical values or your test points. And you're going to take these points that you have picked and you're going to plug these in to your inequality. Okay, so these are going to be our test points. The zeros that you find are going to be your critical values. So they're going to be on a number line. So whatever point we'll say that we maybe have -2 and +2. So when you have those points on a number line, you're going to pick a value to the left of that point, in between that point, those 2 points, and to the right of that point. Okay, once you have your zeros there, you're going to pick some test values. You're going to check this in the original problem. So you're going to check these values in the original problem. The solution is going to be the true values. They will fall in the interval. Make sure you look at your original problem. If your original problem has the equal to symbol, then it is going to be included. So if it is equal to the original problem, you're going to put a solid circle, which means that it is included. It is part of your solution set. If it doesn't have the line underneath it, it's going to be an open circle, which means it is not included. If it is included, remember that you put a bracket. If it is not included, you put a parenthesis. Okay, so our step is to make sure that everything's on one side. That's already done. And the next part is to factor it. And that part has been done. So now we're ready to split those up and solve for each of those. So one of our answers is going to be 0. The other answer, when I set that equal to 0, is going to come out to be -7/2. Okay, so these are going to be my 2 critical values. What I'm going to do with those is I'm going to put those on a number line. Very important that you put the lowest one to the left, and then we have our 0. Okay, so what's going to happen here is we're going to look back to the original problem. And when we look back to the original problem, we see an equal to. So therefore, that means that these circles are going to be closed in. Okay. Now we're going to break this up into different regions. So I'm going to have a region here and then that's going to break up into another region. Okay, so now I'm going to test some values. So when you look at negative 7/2, that would be negative 3.5. So you can pick any number to the left of that. So I'm going to pick negative 4. Okay, a number between those, I'm going to pick a negative 1. You can pick any number there. And then you're going to pick a number to the right of 0. So I'm going to pick 1. And again, you can pick any number that you prefer. Okay. Now, the next thing is you're going to take these values and you're going to plug in to the original problem. So when you do that, if it comes out to be true, we're going to shade that area. So I'm just going to recopy the original problem here as you're learning. And I'm going to put it here as well. And then it'll go on this side. So notice that we're testing 3 sections. Okay. Now, you can do this in your calculator or you can do this in your head. But I'm going to take on the left side, I'm going to take this negative 4 and I'm going to put it in for x in both of those. So I'm going to put a negative 4, parentheses, 2 times negative 4 plus 7. And that number is 4. So I'm asking myself, is 4 less than or equal to 0? So that would be false. So it would not be that region. Okay. Then I'm going to go over here and I'm going to check 1. So I'm going to have 1 parentheses 2 times 1 plus 7. That number gives me 9. Is 9 less than or equal to 0? And I did not put in negative 1, did I? So let's go back and put negative 1. So 1 over here that I just checked, this side is false because 9 is not less than or equal to 0. So the left and the right is false. Let me go back and check the middle. So I'm putting a negative 1. And when I put a negative 1, I get a negative 5. So is negative 5 less than or equal to 0? So that would be true. So that means that my true answers are going to lie in the middle. So when you put your answer, because this is a closed, you would put a bracket on negative 7/2. Remember that comes because it's closed, comma, and then it goes to the number 0 and a bracket. Now the test values are telling you if the region is true or false. You're going to go back to the endpoints that you got with your zeros to put the solution. So when we go to number 2, we do notice that it's all set on the left side, but it's not factored. So we're going to try to break that apart. Multiply to get negative 15. Signs have to be different. And it has to add to be a negative 2. So you would have a 5 and a 3. So now we're ready to get our solutions here. That would come out to be 5 and negative 3. So again, make sure when you draw your number line, you put the lowest one on the left because that will mess you up. The highest one will go on the right. To determine if those zeros are open or closed, you go back to the original problem. Notice that does not have the line under it like the one above. So therefore, these zeros are going to be open. Okay, you're going to pick any number that is to the left of -3. Any number that is to the left of -3. So I'm going to put a -4. If 0 falls in one of the cases, I would definitely pick 0. So 0 would fall between a negative and a positive. And then to the right, I'm going to pick 6. Okay, when you do this, you're going to go back to the original problem. So we're going back to that right there. Everywhere you see an X, you are going to put in the value that you are testing. So we're going to do parentheses, -4 squared minus 2 times -4 minus 15. That gives me a 9. So you ask yourself, is 9 bigger than 0? So since that does work, my answers are to the left right here. So that is true. You probably can put 0 in without a calculator. 0 squared 0 minus 2 times 0 is 0. And then you have -15. -15 is not bigger than 0. So that part would be false. Okay. Then you go to 6. So 6 squared minus 2 times 6 minus 15. So that gives me 9 again, and 9 is bigger than 0. So wherever the truths are going to be the solutions. So we're going to shade the right side. So it failed in the middle, but it was true on the left and right side. Now we're ready to write the answer. So my answer is going to be from -infinity to -3, parentheses, union for or, and then it goes from 5 to positive infinity. So you're listing the rays here that were true, and they're going in opposite directions. That would be your solution. Okay, they're not too bad. It just takes a little bit of time. Okay, so when you look at the next one, you're going to have 3 zeros. So it's already factored. So this one's going to be 2. Then you're going to have -7 and +5. We're going to draw the number line. You're going to start with the least, which is -7. The next one is 2. So you're putting them from least to greatest. And then you have 5. Before you start the problem, if the line is under it, go ahead and put closed circles there. Okay. Remember that you are testing a point to the left. So we would test a point -8. We would test a point between those. So 0 would fall between that. Then I'm going to test 3. And finally 6. Now, when you test those, you are putting that into the original problem. And the truths are going to be where it is greater than or equal to 0. The only way it's going to be equal to 0 is because of the reds here. Okay, so we're seeing if these numbers would give us a greater than 0 value. So we're going to type in -8 and make sure you put parentheses, -2, just like the problem says, -8 plus 7, and then -8 minus 5. So that's going to give you negative 130. So is negative 130 bigger than 0? No. So that part is going to be false. Okay, putting in 0, you would have a negative 2 here. You would have a positive 7 and a negative 5. So that would be negative 14 times negative 5, which is 70. So 70 is greater than 0. So we're going to shade in the middle right here. Okay, then we go to 3. I'm going to ask if you'll go ahead and pause and try to check the video. Check the problems and go ahead and try to finish them and then come back to the video and see if you're right. So as you're returning, you should have got this region to be false. So 3 did not work. And then on the right side, 52 is greater than 0. So then this right side is going to work. Okay, now we need to list our answer. So it is starting at negative 7 to 2. Both of those have a bracket. You're going to put a U. The 5 has a bracket, and it is continuing to positive infinity. Okay, if you feel like you can try the last 3 by yourself, go ahead and try those and then come back and kind of check and see how things are going. And if you're missing something, I definitely would pause the video and listen to the explanation, okay? So in question number 4, we want to go ahead and factor it. So I'm going to take out a GCF of an x, and that's going to leave me with x squared minus 3x plus 2. I'm going to bring down the GCF of an x, multiply to get 2, and add to get negative 3 is going to be negative 2 and negative 1. Negative 2 and negative 1. So one of my zeros is 0. The other one is 2, and the last one is 1. So putting a closed on those points, since it's equal to those zeros, make sure they're in the correct order, and then you're going to test each section. Okay, I'm going to put a negative 1 for this test. For that one, since it's between, you want to do like a 0.5. In between that one would be something like a 1.5, and then we would have a 3. Okay, make sure when you're testing, you're going to the original problem. Okay, so when you're plugging these in, you're going to replace each x with a specific number. So make sure you check those and then come back and check and see if you got the trues and falses right. So when I put the negative 1 in, I got negative 6. So that's not bigger than 0. If you want to copy and paste that, go back and highlight over it, hit enter, and then you can go back and type in your 0.5. So I do 0.5. Then I'm going to do 0.5, 0.5, and then hit enter. So 0.375 is bigger than 0. So this part is going to be correct. And then you can go back to it again and highlight over it and then put 1.5, okay? So that part was false, and then the part to the right was true. So now putting our answer, starting from left to right, 0 bracket to 1 bracket, use the U for or, 2 will be a bracket, and it's continuing to positive infinity. So that's what you would type in when you do your homework. Okay, so resuming at number 5, x minus 2 to the second just means that you have 2 of those factors because you're just squaring. So when I split those apart, I'm going to have a 2 and 2 and -8. Okay, so now I'm ready to draw the number line. And we're going to have to put these from least to greatest. So we're going to have a -8 and then a 2. So we're going to put a solid circle here because those are equal. And then we're going to test. And then when you test, you're going to put them back into the original problem. So be careful on the points that you test. So something to the left of that, I'm going to say -9. 0 does fall between that and then possibly 3. Okay. So go ahead and test those and we'll see what happens. Okay, as I checked, I'm looking for the trues. So this one gave me a true. So I'm going to color to the left. 32 is not less than 0. 11 is not less than 0. So when you put your answer, you're going to have from -infinity to -8, bracket, union. So 2 is included because it was a 0. And then you're going to put the 2 in braces. That's how you will type that into the computer. Okay, so for the last question, I'm going to go ahead and get everything set equal to 0. So I'm going to move everything. So we'll have -2x to the 4th plus 18x to the 3rd, and then minus 2x, 28x to the 2nd is greater than 0. So I brought this over by subtracting. This one stayed the same. I brought that one over by subtracting. You want the exponents to be from highest exponent down. Okay, so the first thing I'm going to do is take out a GCF of a -2, and I'm going to take out an x to the 2nd. So that's going to go to x to the 2nd minus 9x plus 14. That would go to -7 and -2. So now we're ready to get our zeros. So with this one, you would have -2x squared equals 0, x minus 7 equals 0, and x minus 2 equals 0. So when you divide by -2, you're going to get x squared equals 0. You can't have a positive nor negative 0 because it's neutral. So you're just going to put 0 for that one. This one is going to be +7. And the last one is +2. Okay, so remember you want the zeros to be from least to greatest. They're open circles because it was a greater than and it didn't have the line under it. You're going to pick your points and you're going to test. So you're testing to the left, you're testing in the middle, you're testing in the middle again, and then you're testing to the right. So go ahead and test and see what comes up true and false. So when you're checking these, you want to put this number in for this x, and that would be -1 times 18. So that's where I got -18. And then you want to put the -1 in on the other side. And that's where I got 30. So that would not be true. The only one that came up to be true in this one is the 2 to 7. And since it has a parenthesis on it, you're just going to put your answer in parentheses 2 to 7 since it's open and not included. Okay. So that's why these values didn't include this time, because of this symbol here. If it had equal to, you would have included those points as well. Okay, so before we get to the last part with rational inequalities, they have some work in there for you to perform operations with rationals, and rationals are fractions. And you have to pay attention to these because you're going to have to know how to get a common denominator. So notice right here that this is a subtraction. Okay, so when you add and subtract fractions, your denominators have to be the same. So when you have the x minus 2 and the x plus 5, those are two completely different things. So that means my common denominator is going to be those put together. So I'm going to rewrite this with both of those as the denominator. Okay, then I'm going to have a minus, and I'm going to put that as the denominator as well. So now that I've got my common denominator, I notice that this fraction already has the x minus 2 in it. So what it's missing is the x plus 5. So if I multiply this bottom to x plus 5, I have to do that to the top as well. So that is going to give me a 6x plus 30 because you distribute that 6 to both of those. On the other fraction, I'm missing the x minus 2. So I have the x plus 5. So I'm going to have to multiply that one to x minus 2. And you have to be careful with the minus because you're going to be distributing this negative 4. So that's going to give you a negative 4x plus 8. So when you distributed that negative right there, so since I distributed that negative, then this is a plus now, because I distributed the negative 4. Okay, so it's up here at the top. So now I have the same denominator. So I'm going to bring that x minus 2, x plus 8. And that's going to stay the same. And I'm going to put together my like terms in the numerator. So I have a 6x plus a negative 4x. That's going to be a 2x. And then I have 30 plus 8, which is 38. Now, sometimes these do reduce. So I am going to take a 2 out. And when I simplify that by dividing by 2, I get x plus 19. Now, it's not going to simplify any further because I did not get an x minus 2 or an x plus 8. Okay, so nothing's going to cancel. In order to cancel a binomial factor, they have to be exactly the same. So we would go back and type this part in, but you do want to make sure that they don't reduce since you're dealing with fractions, because it is possible. Now, when you have a minus and you have one term, you can look at it like that. But when you have two terms, this minus has to go to both of those terms. So I recommend going ahead and putting a parenthesis here and getting that distributed. So if I put a plus, I would distribute it to both of those, which means now I have this part for the numerator. This part would be that numerator. Okay. Now we're looking at getting a common denominator. So since those are different, I'm going to put that together. Now, this is another way that you can look at the problem. Instead of writing two separate fractions, you can put it all together here. But you do need to kind of go through the same process of asking yourself what's missing here. So what's missing there is the y plus 3. So I have to multiply that to the y plus 3. So I'm going to have y plus 2 times y plus 3. For the bottom one, the y minus 6 is missing. So I'm going to multiply that to the top as well. So I'm going to have plus, and then I'm going to have to FOIL those in a moment. Okay, so what you're going to do next is you're going to FOIL, and then we're going to combine. So you don't ever reduce till the very end of the problem. So you need to FOIL next. So that top, when you FOIL, is going to go to y squared plus 3y plus 2y. That's going to give us a 5y. 2 times 3 is going to be 6. Then we're going to get a negative y squared. That's going to be a positive 6, because a negative times a negative, and a positive 9. So then you're able to add those and get 15y. Then 9 times negative 6 is going to be negative 54. So we want to combine this first after we have FOILed. The y squareds are going to cancel out. You're going to have a 5 plus a 15y. That's going to give you 20y. And then you have 6 minus 54, which is negative 48 over. The bottom is going to be the denominator we had a while ago, y minus 6, y plus 3. Okay, then we're going to think about, can anything come out of those? So if I'm thinking about dividing that, 4, I believe, will come out of the top. And you would have a 5y minus 12. And then the bottom stays the same. Now, remember me telling you, if anything is going to cancel, it has to be identical. So nothing canceled here. So the program might want you to type that in. Just kind of double check that the form, they might accept both answers. Okay, the last one would be the most difficult. So with the last one, before you can get a common denominator, you have to factor them. So it does need to be factored before you can do that. So multiply to get 21 and add to be 10 would be 7 and 3. This would be a difference of 2 squares, so x minus 3, x plus 3. Now, if they have anything the same, you count it one time. So notice that they have an x plus 3. So you're going to count it one time, and then you're going to put the others down. So our common denominator is going to be x plus 7. I count x plus 3 once because they share it. And then I have an x minus 3. Now I'm going to multiply the top here, which is x minus 6. I'm going to multiply that by what's missing. So it has an x plus 7. It has an x plus 3. So I'm going to multiply that to the x minus 3 because it did not have that. I'm going to put my sign down of plus, and I'm going to put my numerator x minus 7. I'm going to multiply by what's missing. So what's missing on that one is the x plus 7. Okay, take a minute, FOIL, combine, and then see if anything will reduce. Okay, after you FOILed, that's what you should have gotten for the top. Then we're going to combine. So I have 2x squared minus 9x. And then you're going to do 18 minus 49, which is negative 31. And then that's going to be over x plus 7, x minus 7. No, excuse me, x plus 7, x minus 3, and x plus 3. The top does not factor, so you would keep your answer just like that. Our last example type deals now with rational inequalities. So rationals are fractions. So you're going to see a numerator and a denominator. Okay, so you're going to have fractions. You want to have everything to one side of the inequality. So you want to have that fraction on one side. Okay, you want it to be a single fraction. That's why you'll have to get common denominators sometimes to put it together as a single fraction. Now, this part is important and where a lot of people struggle. You want to find the zeros. Now, the zeros are coming from the numerator and the denominator. The numerator is going to be the top of the fraction. You can have 0 on the top of a fraction. So you have to pay attention to your original problem like you did with polynomial inequalities. If it has the line under it, it's closed. If it doesn't have the line under it, it's open. In interval notation, a bracket is closed and a parenthesis is open. The denominator is going to be the bottom of the fraction. You cannot divide by 0, okay? 0 on top will give you a 0. But if 0 is on the bottom, it is undefined. Now, you're going to use this value as a critical point, but you have to remember that it's always going to be open because it's not part of the answer. So the denominator for the rationals is always going to be an open interval, and you're going to use that parenthesis. Okay? You're going to put these critical values on the number line, just like we did with polynomials. And then you're going to test the values to the left, in between, and to the right. Make sure you're testing in the original problem. Solutions are the true intervals. As we go to the back of the sheet with example 3, I'm going to take the numerator. So I'm going to take that and put x minus 1 equals 0. And one of my zeros is going to be 1. Okay? Since there is no line under that, it is going to be open. I recommend taking your time and putting that down before you put that stuff on the number line. Then you're going to take the denominator. The denominator is x plus 2. You're going to set that equal to 0, and x is going to be negative 2. Now, since this is the denominator and you cannot divide by 0, that is going to be an open interval as well. Okay, now we're ready to draw our number line. You want to make sure you start with your lowest on the left. So we have a negative 2, and then we have the positive 1. Now, notice that we know now that negative 2 is open, so I'm going to put an open there. We know 1 is open, so I'm going to put an open there. So I know about my circles since I did that at the beginning, because that will mess you up. Okay, so going next, we're going to divide those up into our sections. And I'm going to pick negative 3 to the left. 0 would fall between those, and then positive 2. So remember that we're going back and we're checking this into the original problem. Okay, so looking at negative 3, I would have negative 3 minus 1, and I would have negative 3 plus 2. So we would get a negative 4 over a negative 1, which comes out to be 4. And 4 is not less than 0, so that would be false. Going to the 0 section, I have 0 minus 1, 0 plus 2. So I have a negative 1/2. Negative 1/2 is less than 0. So my answers are going to fall in the middle. Okay, looking to the right side, I have 2 minus 1 and 2 plus 2. So that gives us a 1/4. 1/4 is not less than 0. So there would be no answers in that region. So to put our solution in interval, both of those are open. So I put open with parentheses, -2 to 1. Okay, going to question number 2. Everything is on the left side. It is a single fraction. So the one thing I have to do when I have it as a single fraction is I'm going to start with the numerator. So with the numerator, that's going to be the x minus 5. I'm going to take that and I'm going to solve for that 0. That's going to give us a positive 5. Since it says equal here, that's going to be a closed circle. So I need to make sure to close that in. Looking at the denominator, I'm going to take that and I'm going to set that equal to 0. Now, in order to find these critical values, I'm going to have to factor that. So that would go to an 11 and a -7. So then I would get a -11 and a +7. Since those are on the bottom of the fraction, these have to be open, which means I am using those as critical values, but they're not part of your answer. They're going to help me know where to start testing. Next, I would recommend putting those on the number line. I would also recommend that you're putting those from least to greatest, and then go back and put your circles. So 5 is closed, -11 is open, and 7 is open. Once you have done that, pick some numbers. So I'm going to say -12. 0 would fall in between that. 6 and 8. Okay, and remember that you're testing these in the original problem. Okay, when you test these, I would recommend when you're testing this in the original problem to figure out the numerator's answer and then figure out the denominator's answer. And then you're going to be able to tell, okay, by your sign. So when I got the numerator, -12 minus 5, I got -17. And then I squared -12, which would be 144. Then I subtracted 48 and 77, which gave me 19. Now, is a negative smaller than 0? Yes. So since that is true, I'm going to go ahead and shade to the left. Okay, for 0, I'm going to have a -5 over a -77 because 0 is going to cancel out those x's. Well, we know that a negative over a negative is a positive. So a positive number cannot be smaller than 0. So that would be false. Okay. Then we have 6 minus 5, which is 1. And then you can type your other part in if you prefer. Just make sure you put parentheses around that when you type that in. So 6 squared plus 4 times 6 minus 77 is -17. So a negative is smaller than 0. So that would be true here as well. And then 8 minus 5 is 3. And then you would do 8 squared plus 4 times 8 minus 77. And that's 19. So that would be false because a positive is not smaller than 0. So to put your answer, this would be going from -infinity to -11 parentheses union. This 5 has a bracket and it goes to 7 and that has a parenthesis. So we're almost there. We just have 4 questions left. The last 4 questions would be the most difficult as we're looking at those. So the first thing is you want to make sure that you get the problem with everything on the left side. So I'm subtracting the 3. The next thing you want to do is you want to get a common denominator. So to get a common denominator here, that one is over x plus 2. So that would be a 6 on top. This one has to be multiplied to x plus 2 because it did not have it. Remember, that's where I distributed the -3 a while ago. So that gives us a -3x minus 6 is less than or equal to 0. Then I'm going to put my like terms together. So I get -3x. The 6 minus 6 cancels over x plus 2. So now I have the fraction on the left side by itself. Okay, I'm going to take the numerator, which is -3x. I'm going to set that equal to 0 and divide. So x would come out to be 0. Looking back to the original problem, it does have the line under it, which means this circle needs to be closed. Now I'm going to take the denominator, set that equal to 0. That would be -2. Since that is on the bottom of the fraction, that is open. Okay, now we're ready to draw the number line. -2 would be on the left, and then we would have 0. So I'm going to pick a -3, -1, and 1. I'll go ahead and put my circles. So on 0, we have a closed circle. And on -2, we have an open circle. Okay, and when we're checking these, we're putting those numbers in for x. So what this would say is -3 times -3 over, and then you would have the -3 on the bottom plus 2. So that's going to be a 9 over -1, which is -9. So -9 is smaller than 0. So we'll color to the left. Okay, checking -1, you would do the same thing, except you would put a -1 in those places. So this would be -1 here, and then plus 2. So I get +3 over 1, which is 3, and 3 is not less than 0. It has to be less than 0. Okay, and the last one, you would put a 1 in. So we'd put a 1 here. And then we would have a 1 on the denominator for the other x. So that's going to give me a -3 over 3, which is -1. So -1 is smaller than 0, so it would be going to the right. So our answer to this question would be from -infinity to -2 parentheses. So we put a parenthesis for the open, or we put a bracket and 0 to +infinity. Now, if you feel pretty good about it, you can try the next one. But I did kind of make these to where they're kind of stepping up to where you'll see the tough ones as well. So I'm going to go ahead and bring over the x. We'll leave this alone. And I'm going to get the x to the other side. So I'm going to subtract it. And then when I subtract that x over, it's greater than or equal to 0. So what I'm going to have to do is I'm going to have to get a common denominator. And remember that you can make anything a fraction by putting a 1 under it. Okay, so my common denominator is going to be x plus 9. Now the left side is already over x plus 9, so I just recopy it. My right side that's in blue is not over x plus 9, so I have to multiply that to x plus 9, and then I have to multiply the top to x plus 9. So that's going to give me a -x squared minus a 9x. Okay, then I'm going to put my like terms together. The x squared cancels. I'm going to go with the x first, the linear, -9x minus 36 over x plus 9 is greater than or equal to 0. So here's my single fraction. Okay, Then I'm going to go over to the other side and I'm going to take the numerator and I'm going to set it equal to 0 and the denominator and set it equal to 0. So the numerator, when I add the 36 over, becomes positive. When I divide, I get -4. Now, since this has the equal to under it, this is going to be closed. Subtracting the 9, that one is -9. That is coming from the denominator, so it would be open. So now I'm ready to draw the number line. Be careful because the -9 is your lowest number. So we're going to put a -9 here on the left with an open circle and a -4 on the right with a closed circle. It might be better, just in case you make a mistake getting your common denominator, to go back and check in the original, just where you'll know if you made any errors. A while ago, I checked in the one that I had simplified, and that does work. It's just I want you to be careful because you might make an error in getting the common denominator, and then you think that works, and it really didn't. So if you notice how to check in the original, I went -10 squared is 100. 100 minus 36 was 64. Then you divide that by -10, which gives you -6.4. And you're going to ask yourself if that's greater than -10. And you want to be careful with that because, you know, with decimals and all, the larger the number, when you see that, the smaller. So be very careful with that. So going back to where we were, that's going to be 100 minus 36, which is 64. And just be careful which one you're plugging in, okay? So I'm going back to the original one on this one. -10 plus 9 is -1. So then I get -64 is greater than -10, okay? Be careful with that negative, and that would be a false. And then we have -5. So we would have 25 minus 36, which would be a -11. -5 plus 9 is 4. And we're asking ourselves if that's greater than or equal to -5. So -11 fourths is going to be -2.75. And that is going to be bigger than -5. Then we have -36 over 9 is greater than or equal to 0. So I'm putting in 0 here. And that would be -4. And that is not greater than or equal to 0. So our answer would be parenthesis -9 to -4 with a bracket. Okay, so I'm going to set this equal, greater than or equal to 0. So we'll subtract that over. And then I need to get me a common denominator. So my denominator is going to be x times x minus 6 because those are different. This is different from just x. So I'm going to take the 2x and I'm going to multiply by x minus 1. And I'm going to multiply it to x minus 6. So I'm multiplying by what each of the denominators did not have. So then I get a 2x squared minus x plus 6. Okay, and I have everything together. None of those are like terms, so I can't put any of that together. So now I'm going to take the numerator and we'll bring it down and try to factor that. So I have a 2x and a 2x, excuse me, a 2x and an x. So then I'm going to try 3 and 2. So when you try, you want to put the minus and minus, and you don't want to put the 2 here. So I'm going to put a 3 and a 2. And you see that I'm not able to factor this. So I could use the quadratic formula to be able to see kind of what's going on. So we could check out our discriminant and see if it's going to be able to be factored. So we would do b squared minus 4ac, and you see that you get a negative 47, which means those are going to be imaginary solutions. So that tells me I can't do anything with the numerator, okay? So I can't do anything with the numerator if it's not going to factor and it has negative answers. But I can still work it out with the denominator. So with the denominator, you're going to have x equals 0 and x equals 6. Now, since that's on the bottom, these are going to be open. So we use a 0 and a 6, and we need to put open. Okay. Then you're going to still test like we normally do. Okay. And you're going to highlight your truths. So I put that in the original, and this part would be true. And going back to the original, it's 2 times 1, which is 2. 1 minus 6 would be negative 5, is greater than or equal to 1. So negative 2/5 is not bigger than 1. Then I'm going to go to 7. 2 times 7 would be 14. 7 minus 6 would be 1. Is that greater than or equal to 1/7? Yes, 14 is bigger than 1/7. So then you would have answers to the right. Okay, so your solution to this is negative infinity to 0, union 6 to infinity. So I've got to set this on one side. So I've got to move this to the other side. So I need to move to the left. So I'm going to subtract. It's going to be a minus in front. Okay, now we're going to get a common denominator. So that would be both of those together. If you remember, we're going to go ahead and distribute that minus, because you're not just subtracting the x, but you're also doing the 5 because they're stuck together. So we're going to go ahead and change that like we did earlier to fix that. I'm going to take my x minus 4, and I'm going to multiply that to x plus 7. And then I have a plus, and then I'm going to take the negative x minus 5, and I'm going to multiply it to the x minus 5. Okay, so now you need to FOIL. So you need to FOIL the top. So we're going to get at the top here, x squared plus 3x minus 28. Then I'm going to get a negative x squared. That would be 5x minus 5x, which goes away to 0. And then that's a positive 25. My x squared and negative x squared cancel out. I'm going to get a 3x negative 28 plus 25 is going to be -3. And then it's going to be over the denominator. And we have greater than or equal to 0. Okay, now we're going to take the numerator and set that equal to 0. So we get 3x equals 3. So x would be 1. Since it's equal to, it's a closed circle. We're going to take the denominator. That would be 5 and -7. Since those are in the denominator, those are going to be open. So now we're ready to test those points. So I'm going to go ahead and put the points down. -7 is the lowest. Then you go to 1 and 5. Putting the circles, closed, open, open. So we'll say -8, 2, 6, and 0. Okay. Now you're going to check those and see which ones work. Okay, and then the answers will be the truths. So when I tested to the left, it was false. And I'm just going back to the original. So if I put 0 in, I'm getting -4 over -5. And I'm seeing if that's bigger than or equal to 5/7. So that's going to be 4/5. So if you have fractions to check like that, you want to look at your decimal. So 4/5 and 5/7. So that would be true because 4/5 is bigger than 5/7. So we'll color in this part. And then you can check your 2. 2 minus 4 is -2. 2 minus 5 would be -3. 2 plus 5 is 7. 2 plus 7 is 9. So is 2/3 bigger than 7/9? So 2/3 is 0.6. 7/9 is 0.7. Ooh, there's a 6, 7. So that would be false. Okay, and then 6. 6 minus 4 is 2. Then we have 6 minus 5 is 1. I'm just going back to this original part right here. Okay, is that greater than or equal to? Then I have 6 plus 5, which is an 11. And 6 plus 7, which is 13. So is 2 bigger than 11/13? Yes, that would be true. Okay, so I definitely say that's probably, these last ones were probably the hardest ones. So to put this answer, we would have a parenthesis, -7 to 1 bracket, union 5 to infinity. And I do hope this helped. Don't forget to upload your notes to D2L because this does count as part of our attendance. And I hope you have a great day, and hopefully we'll be able to get back together later this week. Stay safe.